Alright, so we did a light controller circuit, and the basis of the circuit is built around this thing right here. This is called an LDR, or a light dependent resistor. It's also called a photoresistor. And so the brightness of this green LED right here can be controlled using the LDR. Basically what an LDR is that it's made of a high resistance semiconductor. If any light falling on the device is of high enough frequency, meaning of how bright it is, the photons are absorbed by the semiconductor and they give the electrons enough energy to jump onto the conduction band. And the conduction band is the little wavy thing you'll see on the LDR. Um, the resulting free electrons and everything else, they conduct electricity, and thereby they lower the resistance and making the LDR shine brighter. Alright, so let's put our battery in. And this is, if you notice, this is the LDR on its normal brightness. We're not blocking any light, but we're not adding too much light either. So now I'm going to put my finger on the LDR, and so let's see what happens to the LED. It's decreasing every time I put my finger on it, blocking off light, meaning there isn't enough light to give enough energy to the electrons to jump onto the conduction band. So now let's see if we can shine some more light on the LDR. You can see it's going way more intensely. And that's how an LDR works. And that's our circuit. LDRs, or light dependent resistors, are mainly used as trigger mechanisms. They're used in watches. Some watches, they start to glow in the dark so that it is possible to see the time without having to press any buttons. It is the LDR that allows the watch to know when it has gotten dark, which is usually at night, and that changes the brightness of the light emitted. LDRs are also used in fire alarms. The fire alarm is very important in crowded residential complexes. Let's look at a crude fire alarm circuit. This alarm works if there is smoke generated by the fire, which crosses the LED and covers the LDR sensor so that the incoming light in the LDR is reduced. Lack of light causes the resistance in the LDR to increase, thus generating voltage in the COB chip to create sounds. Some of the problems we encountered while doing the light controller circuit was that we followed the initial diagram and it didn't work for us. So what we did was that we got rid of the 150 ohm resistor, and instead we put in another resistor, which was the LDR, the light dependent resistor, and that worked for us. I suspect that the 150 ohm resistor was too much resistance, and therefore the circuit didn't work. So those were one of the problems we came to make the LDR circuit work.
Okay, so here we have another circuit. Now the main difference between this circuit and the previous one is the resistors, whereas in our previous circuit we used the light dependent resistors, where the brightness of the bulb changed upon how much light you shone into the resistor. In here the human body acts as the resistor. So let's see how it works. When I put my two fingers onto these two wires, we can see that the bulb starts to glow. Now my body is acting as the resistor here, and the electrons start flowing through my body and into the other end of the circuit. Now when I wet my fingers and place them on the wires again, we can see that the brightness has greatly increased. Now this is due to the fact that since I wetted my fingers, it will conduct electricity better, allowing more electrons to flow, which decreases the resistance of the circuit, which therefore makes the bulb glow a lot brighter. And that's our circuit. Yeah.
Now we encountered some problems in creating our pressure tester circuit. Our chief problem was with the 150 ohm resistor. Now we speculated that this resistor may have provided too much resistance, thus allowing the bulb to not glow. To remedy this, we took out the 150 ohm resistor and we replaced it with the two loose ends of the wires, and thus using my body as the resistor. And this solves our problem for our pressure tester circuit.